stream. Let me check. The stream is up. Okay. Okay. Let's solve some algorithms today. Just typing the input and output format. Stream elements, is it? I'm not sure whether I have put the commands there, but yeah, let me see. Yes, stream elements. How is it? It's not authorized. Cancel. Okay, authorize anyway. I'm just checking this stream elements thing. I'm not sure when I activated it. I think I did it for the commands, chat commands. Yeah, I think I did it for those custom commands. Yeah, let me just switch it off today and just put I'll just leave it. Okay. Okay, let's focus on this. Okay, this is problem name would be 2 number sum, difficulty is easy. Okay, write a function that takes a non-empty array of distinct integers and an integer representing the sum. If two numbers in the input array sum up to target sum, the function should return them in an array in any order. If no two numbers sum up to the target, the function should return an empty array. You can't add the single integer to itself. Okay, so in this case 5 cannot be added to itself, so it should be two distinct array and that should return. So in this case, so practically brute force way you would go with one while loop and other while loop. You pass through each one of them and then the second loop will again pass. You compare with each other, then do the things. That this would be big O of n to the power 2. Yeah, so this is it. So another technique would be just while loop while I is less than j, so you are iterating from here and you are iterating from So one by one come from the side, and the other pointer will come from the side. Keep on checking if until I and j meet at a junction. In that case you will return empty, otherwise if you find the sum then you return it. Okay, now next thing is, okay, before that you need to sort. This is important. Sorting the array is important. So generally when you use the built-in sort method, it would be log of n or n log n. So this becomes this is O of n, and this would be generally n log n or a log n kind of stuff. So even if it is n log n, we'll take the worst case, so it will be n plus, it would be n log n, or best case log n, and then this would be n O of n. So n plus n log n, so worst possible case would be n log n. So yeah, so that's it. So next one was oh man, validate subsequence. What is the problem name? This is validate subsequence. So what is the problem? Given the two non-empty arrays of integers, write a function that determines whether the second array is a subsequence of the first array. Okay, input. So let me get some more input. Okay, I'm copying it from some unknown source like LeetCode. So pardon me. This is just for my reference. Okay. A subsequence of an array is a set of numbers that aren't necessarily adjacent in the array, but that are in order as they appear in the array. Okay. The numbers 1, 3, 4 form a subsequence of array 1, 2, 3, 4. Okay, it cannot be a continuous sequence, it can be a discrete, and so do the numbers 2 and 4. Note that the single number is an array and the array itself valid subsequence of the array. Okay, let's see what's the sample input. Okay, and the output would be true. Yeah, 1 6. Yeah, output would be true. Okay, so here also we'll deal with the same this one. So this is pretty straightforward. You come from this side and you come from the side here, so it has to be in the same order. So what we'll do is I less the array count, so pass through entire array, and j less than sequence count entire array. If I matches j, then increment both, and if we finish the sequence array count, if we are at the end of this one, let's say true. If it doesn't match, keep this one. I am here. Next I need to find 6 somewhere. Yes, 6 is there. Till then I increment only the I. Yes, and then we are done. So yeah, so this is it. So problem 2 is done. Now this is problem 3. Find the closest value in the BST binary search tree. Write a function that takes a binary search tree and target integer value and return the closest value. You can assume that there will be only one closest value. Okay. There can be 12, there can be 14. Okay. Each BST has a node, each BST node has an integer value, a left and a right, and node is said to be a valid BST only if it satisfies the BST property. Its value is strictly greater than values of every left node and values of every right node. Children nodes are either valid BST nodes themselves or none or null. So in this case 10, 5, 2, 5, 1, left is good, right 15, 13, 22, 14. What about 5 and 5? So value is less than or equal to the value of, okay, less than or equal to, so this is equal, this looks fine. 13, 14. Okay, so now we need to solve this. So other two problems I had solved earlier. That's why I just explained I forgot to stream, or I was lazy for streaming. Let's do this. So you have binary search tree, it has a value and it has a left subtree and right subtree in it with values. Each node will be initiated with left and right node as null. Okay, let's put some dummy data here for the time being. Need to create, I am writing it in the Swift background. So vst value is 10. So I need to create what's the easiest way to create? Let's just create. I'm still not writing the algorithm. Let's just create node 1 this one. So let's just copy paste this. How many nodes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Let's get a value of 10, 5, 1, just 2, node 1, and there we have 15, 13, 14, 22. Okay, now we have all the nodes. Pointer, so 10 has a left, so n10 dot left equal to n5, say, okay, n10 dot right equal to 15. Okay, part 1 done. 15 and 5 dot left equal to 2. And then 5 dot right equal to n5, let's go 1. Okay, we are good to go. n2 dot left equal to n1. So we are done with the left subtree basically. Now we need to do with the right subtree. 15 has 13, 13 has 14, 15 has 13, 15 dot left and 13, yep, and n13 dot right equal to n14. Okay, not 14, and we have 15 right and 15 dot right to n22. Okay, so we have created this tree, and now we need to find the closest tree, and then for a target sum of 13. So yeah, let's start. So difficulty, okay, we forgot to add the difficulty here. Difficulty is easy. Okay, so what we have 10, 5, 2, 5, 1, 15, 13, 14 and 22, and target sum is 13. So this is the target. So how do we traverse? We start from the root. Okay, check the difference. The difference 13 minus 10 or 10 minus 13. So we start with the root. We'll have a variable say difference, so we'll mark that here. So at root the difference is minus 3. Let's say this minus this. Okay, node minus target value. Okay, so we'll keep this node minus target value. 10 minus 13 is minus 3. So check if it is greater or smaller. So actually target value is greater than 10, so we'll move right. So ideally that should be the case, we should move right. What if this was 11? This seems to be minus 1. So yeah, correct. So we should move right because the target value is greater than the root. And now when you come here, 15 minus 13 is 2. So this is greater, the node is greater, so move left. 13 minus 13 equal to 0. So needs a closest value. Okay, and so this is equal. So when it is equal, as mentioned in the problem, BST node it's a valid BST. No, if and only if satisfies BST property, whatever its property, its value is strictly greater than the values of every node to its left, and its value is less than or equal to the values of every node in the right. So we have to traverse right here. So because this was equal, because this is 0, so to traverse right, so 14 minus 1, 14 minus 13 equals to 1. So which out of this now, which is the, and at this and at this, now we don't have any left or right subtree after this, so we are good to stop here. So 0 is the lowest, so out of this, so we need to find this, which is the lowest. Okay, now definitely this, the def here, this can't be, so we need to make this as absolute value, so this becomes 3, and when it compares here we can replace this, because 3 is greater than 2, so we can replace this with 2. So 2 is greater than 0, we replace this with 0, and 1 is greater than 0, so 0 stays. So this diff value, wherever we got, have to return. So we, instead of having a, okay, we need to store the diff and the node value, and we need to return the node value. So this makes sense. Okay, let's just go ahead and code it. We have created, we know the BST, while tree dot left we'll do the standard Swift thing, guard let t equal to tree, if that is nil return, if there is no tree return -1, if t dot left do we have while let? I'm not sure. Yeah, we have. Let's make it if let. How do we start? Okay, we'll have a while loop first. don't need this. Where def is equal to we need to start with the int where def is equal to t dot value minus target. So let this be the initial value, and where node value equal to t dot value. Okay, let this be the start condition. While it is equal to 3, let's make it node. While node is equal to 3, that means we have the value for the node and we need to traverse. So how do we go? So now we need to check whether the target value is greater than or less than the node value. If node dot value is less than 3 dot value, no sorry, target, then okay, we can't. Okay, this looks fine. I'm making it complicated, I'm not sure. Okay, now it has to traverse if it is less, if value is less than the target, value is greater than the target. So if this value is this node value is greater than the target, then it suppose this was 1, so it has to come here, so left subtree. So what do we do? Node equal to n dot left, else node equal to n dot right. Okay, now this is done. Okay, now that is for traversing. Now the actual logic comes here. So if val minus target is less than the current def, if val minus target, if the node value minus the target is less than the def, existing def, how do you get a absolute value in Swift? Swift absolute integer. ABS, awesome. Will that work? Returns the absolute value of the given number. Okay, great. Okay, so and we don't need this with one loop. Okay, let's just try and run this. There's nothing to print. It's the 10. So where did we miss? we missed something. Let's just print this is 3. Okay, it ran 3 times, so this didn't run, so we are good. We are traversing right, but we traverse right multiple times. If val is greater than, so this should not be 3 times. 1 2 3. So it came here, here, and then here, so that should not be the case. So our while loop is correct, but this condition, something has gone wrong. Oh, if val is greater than target, so target was 13, val is target, it should go left. Why didn't it go left? So our construction was wrong. So somewhere n10 dot right is n15. This one. So this is node 5, left right, node 2, then n15, left is n13, n15 dot right is 22, n13 dot right is n14. So this looks fine. n10 it went to n15, right? Yeah, so in the second case it was the problem. So after n15, left was n13. This is the problem. We never, classic issue of copy paste. Okay, now let's see what happens. Yep, 13 is the right answer. Thank you. O of n. So generally what happens is, so this algorithm works with O of log n. Why log n? Because we are eliminating half each time. So we check here, we eliminate this half, so this entire half is gone. Then we check here, this entire half is gone, and then we check here, this half is gone. So yeah, works fine. Let me check the solution once. Okay. Yep. So I just verified the problem and this looks good. So we have covered third solution. So this is the average case, worst case is n log n. Sorry, worst case is O of n. So why O of n? So let me give you an example why O of n. So let me select this. Okay. Okay. So 10, 5, 2, 1, 3. Sorry. So if there is only the subtree, or if there is like this, so and you have given value 21, or here in this case you have given a target value of 0 or target value of 21, and this is the tree. So these two are cases, so you are traversing through each, so this is n, and here also you are traversing n, so worst possible case is n. Okay, that's good. Okay, cool. We're good with this. So we had a good this one. Okay. Tomorrow let's dig into a couple of more questions. I think I'll go with this. So every day one solution looks fine. Okay, cool. So let me see. Okay. So this looks good. So what would be the next question? So next question would be branch sums. Okay, I'll have the question ready tomorrow and we'll solve it together. Okay, this was pretty good. Did great. Thanks folks.